Hello everyone, I am your friend Shadab Imam and currently we are dealing with the topic of game theory. In today's lecture we are going to see how we reduce a matrix using the dominance rule and solve the problem. So please watch this video till the end, and if you are new to the channel, please subscribe the channel and don't forget to hit the bell icon. So in any game theory problem, our first step is to find out that if there is a saddle point or not, and if there is no saddle point we will reduce the matrix into 2 cross 2 size. But how we are going to reduce the matrix? So we generally reduce the matrix using the dominance rule. So in this problem we will see how we use the dominance rule in the game theory problem. So let us move on to the problem. Here the problem says that A and B play a game in which each has 3 coins, a 5 paise coin, a 10 paise coin and a 20 paise coin. Each player selects a coin without the knowledge of the other's choice. If the sum of coins is an odd amount, A wins B's coin. If the sum is even, B wins A's coin. Find the best strategy for each player and the value of game. So in this problem it has been said that there are 2 players each having 3 coins, a 5 paise coin, a 10 paise coin and a 20 paise coin. So each player put forward a coin without the knowledge of others' choice. So when the sum of the coins is odd, then player A wins player B's coin, and if the sum is even, player B wins player A's coin. So let us first of all prepare the payoff matrix here. So let us prepare a payoff matrix for player A. Now let this be player A and this be player B. Each player has a 5 paise coin, a 10 paise coin and a 20 paise coin. So this is for A, and player B also has 5 paise coin, 10 paise coin and a 20 paise coin. So if player A chooses 5 paise coin and player B also chooses 5 paise coin, then the sum of these two is 10. So when the sum is even, then B wins A's coin. That means A loses his 5 paise coin. That means A has a loss of 5 paise. So here we will have the value as -5 because A is losing 5 paise. Similarly, if A plays 5 paise coin, B plays 10 paise coin, the sum is 15, which is odd. So when the sum is odd, player A wins player B's coin. That means here player A wins 10 paise coin. That means player A will gain 10 paise. Similarly, if player A plays 5 paise and player B plays 20 paise, the sum is 25, which is odd. So here player A wins B's coin. That means player A will gain 20 paise. Now if A plays 10 paise, B plays 5 paise, the sum is odd. So here also player A wins B's coin. That means player A will gain 5 paise. And here if player A plays 10, B plays 10, then the sum is 20, then player A loses his coin. That means player A will lose 10 paise. So this will be -10. Here also if A plays 10, B plays 20, then the sum is 30, which is even. Then player B wins A's coin, so A will lose 10 paise. So this will be -10. Again if A plays 20, B plays 5, the sum is 25, which is odd. That means A wins B's coin, so B's coin is 5. That means A will gain 5 paise. If A plays 20, B plays 10, the sum is even. That means B wins A's coin. So player B will gain 20 and player A will lose 20. So this will be -20. And if A plays 20, B plays 20, the sum will be 40, which is even, and here also player A loses 20 paise. So we have made the payoff matrix for player A, and now in any game theory problem we will first see if there is a saddle point or not. So let us quickly find the saddle point. In order to find the saddle point, we will first calculate row min, that is minimum value in each row. So in row 1 minimum value is -5, in row 2 minimum value is -10, in row 3 minimum value is -20, and among these value the maximum value is -5. So this -5 will become maxi min value. This is maxi min value. Similarly, we will calculate the column max, and in this we will select the maximum value in each column. So for column 1 maximum value is 5, for column 2 maximum value is 10, for column 3 maximum value is 20, and the minimum among these value is 5. So this 5 will be minimax value. So from here we can see that the maximum value is -5 and the minimax value is +5. That means both the values are not equal. In this particular game we can see that the maximum value is the value of -5 and the minimax value has the value of +5. That means the -5 and +5 are not equal. So minimax value and maximum value are not equal. This suggests that this game has no saddle point. So we know that now in this game saddle point does not exist. Now we will try to reduce this matrix using dominance rule. Now to understand the dominance rule, I will first erase this. To understand the dominance rule, we need to see the payoff matrix first. So this is the payoff matrix for A, and A would like to play the strategy which will give him the maximum gain. Similarly, B will try to play the strategy which will reduce the loss, or we can say which will minimize the loss for B. So the dominance can be done in two ways, that is for row domination and for column domination. So we can say that player A has the strategies in row. That means player A will play that particular strategy which is better than the other strategies, or we can say which will give more gain than other strategies. So if there is any strategy in any row, or we can say if there is any row which has each element of that particular row inferior or lesser than any other existing row, then that particular row is dominated. So we can write here, in row domination or in row, the dominance rule can be like this: the dominated row must have each element lesser than or equal to any other existing row. So if we consider the row, or we can say if we consider the strategies for player A, the dominated row, that means which row has to be eliminated, the dominated row must have each element of the row lesser than or equal to any other existing row. Then the dominated row, or we can say each element of the dominated row has to be less than or equal to the element of the other existing rows. Similarly, when we consider the dominance rule in column, we can say here that player B has his strategies in column, and player B will try to minimize its loss. So in column, the dominated row, the dominated column will have the maximum value in each element, or we can say the dominated column must have each element greater than or equal to any other existing column. So the dominance rule for row is that the dominated row must have each element of that particular row lesser than or equal to the other existing elements of the column row. Similarly, dominance rule for column is when the dominated column will have each element of that column greater than or equal to the elements in any other existing column. So let us see what this means. In this particular payoff matrix, we can see that there are 3 rows. So let us first compare row. So I will say player A has 3 strategies: strategy 1, strategy 2 and strategy 3. Now let us compare strategy 1 with strategy 2. Here we can see that strategy 2 is greater than strategy 1 for the first element, that is 5 is greater than -5, but here -10 is lesser than 10. That means each element is not greater, so dominance is not possible among 1 and 2. Now let us compare 1 and 3. So -5, 5, that means 5 is greater than -5. Here -20 and 10. Here 10 is -20 is lesser than 10. So here it is greater, here it is lesser. So the dominance between 1 and 3 is also not possible. Now let us compare row 2, or we can say strategy 2 and strategy 3. Here 5 and 5, these two are equal. Here -10 and -20, that means this value is greater than this, and here also -10 and -20, that means this value is greater than -20. So this suggests that each element of strategy 2, or we can say each element of row 2 dominates each element of row 3, or we can simply say row 2 dominates row 3, or we can say that row 3 is dominated by row 2, and this is because each element in row 3 is lesser than or equal to each element in row 2. So we have written here dominated row must have each element lesser than or equal to any other existing row. So in row 3 each element is lesser than row 2, that's why row 3 is dominated, and now as a result we will eliminate row 3. So let us eliminate row 3 and find the remaining matrix. Now let us see the new and revised payoff matrix. Here row 3 is eliminated, so row 1 and row 2 is remaining, and similarly here row 1 column 1, column 2 and column 3 are remaining, and the values are, just a second, the values are -5, 10, 20, and this is 5, minus 10 and minus 10, sorry, so this will be minus 10. Now let us see here again that comparing row 1 and row 2, this is minus 5, this is plus 5, this is plus 10, this is minus 10. So there is no dominance between row 1 and row 2. Now let us see the column first. So we can see here that if we compare column 1 and column 2, this is minus 5, this is plus 10. So this is greater, and here it is plus 5 and minus 10. So this is lesser. That means between column 1 and column 2 there is no dominance. Now let us compare 1 with 3. This is minus 5, this is plus 20, this is plus 5, this is minus 10. So here also we do not find any dominance between column 1 and column 3. Now let us compare column 2 and column 3. Now comparing column 2 and column 3, we can see that this is 10 and this is 20. That means 20 is greater, and this is minus 10 and minus 10, both are equal. So we can say here that here column 3 is dominated by column 2, because in dominance in column we have seen that dominated column must have each element greater than or equal to any other existing column. So here the values in column 3 are greater than and equal to column 2. That means here column 3 is dominated by column 2. Now as a result we will eliminate column 3. So now let us eliminate this column 3. So now we can see here that our payoff matrix has been further reduced into 2 cross 2 matrix, and by comparing further we can see that this is negative, this is positive, this is positive, this is negative. So there is no dominance between row 1 and row 2. Similarly, if we compare column 1 and column 2, this is negative, this is positive, this is positive, this is negative. That means in column 1 and column 2 also we do not find any dominance. So this could not be reduced further, and now once it has been reduced to a 2 cross 2 matrix, we can solve this by using the mixed strategy. So let us solve this particular problem. In order to solve this, we need to calculate the oddments here. And now what is oddment? Oddment is the difference between these elements ignoring the sign. So this is 10 minus of minus 5 is plus 5, so 10 plus 5 is 15, and now this difference is written against the opposite row. So this is 15, so here it is 15. Similarly, we will find the difference between the elements of second row. So this is 5 minus of minus 10 is plus 10, so 5 plus 10 is 15, and this 15 we will write in against the opposite row. So here also it is 50. Similarly, we will calculate the difference for column also. So this is 5 minus of minus 5 is plus 5, 5 plus 5 10, and this 10 we will write against the opposite column. So here it is 10, and this is 10 minus of minus 10 is plus 10, 10 plus 10 20, and this 20 we will write against the opposite column. So here it is 20. So we have calculated the oddments here, and now let us calculate the probabilities. So this is player A, this is player B, and the probability of player A playing strategy 1 can be given as 15 divided by 15 plus 15. So this is 15 divided by 15 plus 15 is 30. So this is equivalent to 1 by 2. Similarly, the probability of player A playing strategy 2 is given by this and it is 15 divided by 15 plus 15. So again this is 15 divided by 15 plus 15 is 30, which is equivalent to 1 by 2. And this suggests that player A will play strategy 1 half time, or we can say 50% of time. Similarly, player A will play strategy 2 half, or we can say 50% of time. Similarly, we will calculate the probabilities for player B also. So for player B, the probability of playing strategy 1, so let this be Q1. This is 20 divided by 20 plus 10. So 20 plus 10 is 30. So 20 by 30, or we can say 2 by 3 is the time for which player B will play strategy 1. Similarly, for strategy 2, we will calculate the probability of player B playing strategy 2, and this is 10 divided by 10 plus 20, which is 10 divided by 30, or we can say 1 by 3. Now this suggests that player B will play strategy 1 2 by 3 times, or we can say 66.6% of time, and player B will play strategy 2 1 by 3 time, or we can say 33.33% of time. From here we can see that the optimal strategies for player A and B. So for player A, optimal strategies can be given as 1 by 2, 1 by 2, 0, because player A has total 3 strategies, as we have seen in the first payoff matrix, and player A will play strategy 1 50% of time, and player A will play strategy 2 50% of time, and because strategy 3 is eliminated, this shows that player A will play strategy 3 0% of time. Similarly, for player B, the optimal strategy can be 2 by 3, 1 by 3 and 0. Now this suggests that player B will play strategy 1 2 by 3 times. So here 2 by 3. Player B will play strategy 2 1 by 3 times. So this is 1 by 3, and because strategy 3 is eliminated, that means that player B will play strategy 3 0% of time. So by this we have calculated the optimal strategies for player A and player B. Now to calculate the value of game, we have seen how to calculate the value of game. So the value of game can be calculated simply by taking any row or any column and multiply it with corresponding probability. So here let us take row 1. So this is -5 multiply by 20 by 30, or we can say 2 by 3, plus 10 multiply by 1 by 3. So plus 10 multiply by 1 by 3. So this is minus 10 by 3, this is plus 10 by 3, which is equivalent to 0. So here we can see that the value of game is coming as 0. So if we consider row 1, row 2, column 1, column 2, the value of game will be same, because we can see here that the sum of the oddments horizontally and vertically are equal. So for horizontally 20 plus 10 is 30, for vertically 15 plus 15 is 30. So whenever the value of oddments horizontally and vertically are equal, then we can say that this particular value of game is same for player A and player B. So here we have calculated the value of game for player A and player B, and the optimal strategies for player A and player B. So I hope you understand. We will do some more problems on how to solve the problems using the dominance rule. And if you like the lecture, please share the lecture. Have a nice day. Thank you.